coming.
Thank you also for
Hopefully, inshallah, the presentation will be good. You will like it, inshallah. Okay. They did a good job in the air conditioning system for a commercial building. Just يعني general idea about the project. They work as a consultant. The consultant is doing. I provide them with a small mall with 3 floors and underground
okay.
with the AutoCAD professional one. I get the drawing from one of the architecture offices and so on with all the details. Their job was to apply what they learned in the air conditioning course and what they are learning in this course to work as a consultant for HVAC. So at the end, they should give the client what system to use, the size, even they choose from the catalog. Okay. So now the floor is for you. You can start your presentation.
Bismillahirrahmanirrahim. Mr. Ahmed Khalid, Mr. Wahidin, welcome to our final presentation, and we are glad to have you here and to be with you. And before talking about our project and before I introduce our work, I would like to introduce my group member and I, Ali Zain, Mishal Latel, Hussein Faqih, Dawood Naban, and Ali Zadeh. So first of all, I will talk about our outline, and it's about our PowerPoint presentation, how it will go. The first part is about the methodology. It's about the steps that we follow from the beginning until the end of the presentation. Then we will talk about the literature review. It's about some background researches that we did to see the methods, the difference between them, advantages, disadvantages of them. Then we will show our best solution based on some criteria and constraints, and we will show our standards. After that, we will talk about the method of cooling load, and we will show our hand calculation and have software results, and we will do a small comparison between them to see if we were accurate or not. Then we will talk briefly about the duct design, and we will show the quantity table, then through the conclusion, future work, and work plan, and last but not least, the reference. So first of all, the methodology, or I would like to call it engineering design process, because before creating any project, the engineer should follow those steps so to have everything clear and to have the best results. So problem definition, we should know what we want to design, which building we are dealing with, why we want to do this, what is the specification of our building. Then we will talk about the central air conditioning systems, the difference of them, the advantages and disadvantages of them, and based our criteria and constraint, it will lead us to take the best solution. Then we will show the calculation, the result of the hub, the duct design, and we will show the quantity table of both indoor and outdoor units. So the problem definition, as a senior project, we are working on designing a central air conditioning system for a commercial building in Kuwait, and this is our location. And the building is contained from 3 floors, the basement, ground floor, and the first floor. And the capacity of the building, it's fit for more than 700 people on it, with an area exceed 1,000 meters square. So furthermore, for our design, we used the latest system in the markets that have been being used for all modern and the new buildings, and it's called the VRF system, Variable Refrigerant Flow, and we will talk about it in details by viewing the disadvantages and advantages of it, and in details with Mishal Latel.
Now we will talk about the all air system, the types of the AC conditioning system. The first of all, the all air system, the all water system, the air water system, finally the VRF system. First of all, the all air system, the advantages, it's easy to change from summer to winter mode, and it saves energy. The disadvantages, it's possible in high building, and the installation is very hard on the already building. The oil water system, the advantages, it's used in the existing building which is completed, and it's need a small area compared with the oil air system. The disadvantages, it's have a noisy, high level of noisy, and it's need a high level of caring compared with the oil air system. When it's come to the air water system, it's have a good and positive airing with any condition. But the disadvantage, it's high expensive, and it's need a backup heat system. When we talk about the best solution, the VRF, variable refrigerant flow, to give cooling and heating to the individual zones. HVAC system use outside units connected to the several indoor units, refrigerant piping. Many experts now recommended that the individual uses these types, especially in commercial building, which our project talking about, where the system control make changing the temperature in each room simple. The advantages, it's easy to control the temperature of the room, and high of efficiency and low noisy level. When come to the disadvantages, it's have a high cost, but it's probable that need a backup heating system. And the most advantages for the VRF system, it's have a flexibility provided of the piping, and the technology make this VRF system is needed strongly nowadays. When we go to the criteria, first of all, the cost. The cost is have an high cost, and the quality, it's have an high quality compared with the traditional system that used before. The efficient ductwork, it's have good efficient ductwork compared with the traditional systems. The energy consumption, it's
if you make a professional presentation, so they don't let you read from the papers, okay? So this is, if you want to...
I don't need that, just words.
I mean, if you...
Not a big sentence, small words to remember what I talk.
Okay, because you cannot compare.
He already wrote them in Arabic, not in English.
It doesn't matter that, so you cannot read always from the papers, okay?
Okay. When it comes to the air quality, it's have high air quality, and when it comes to the compatibility, it's not need to replacement. And the comfort zone, the range of the comfort zone is 22 and 24 degrees, and the prevent good humidity. And now Alize will complete.
Hello, doctors. I will continue from here about the standards and codes. Thank you, Michelle. The standard we used in our project is ASHE standards. Yeah. Standards are very important because they lead the group in one way to be professional and acceptable worldwide. Our standard is ASHE standard, which refers to American Society for Heating, Refrigerant and Air Conditioning Engineers. We use the three standards. They are talking about commercial buildings and HVAC systems, which leads for good good quality of air and heat comfort. Moving on to the next slide, I second, of course, we needed external constraints that leads our project in one way to choose the best design for it. The first one is the cost effectiveness. Of course, it's an economical category, but it's not about having the same project with a low cost. It's about having the best system, but saves more money for several decades. The second one is the ducts and ventilation. We classified this one as environmental because it saves, because it cleans the air from dust and the vents around us. The third one is cooling loads and energy efficiency. This is not updated now.
Okay, مشكلة.
The third one was supposed to be this one, health and safety instructions, which is, of course, in health and safety category, and it's about having healthy air and clean. The last one is going to be the energy efficiency and the cooling loads. Doctor, this is updated in a new one, but this is not the last version. It's our program.
Yeah.
The cooling loads and the energy efficiency, they are classified in sustainability category. For the energy efficiency, it's important to have a good efficiency for our system. And for the cooling loads, I will explain in the next slide because it has 6 methods. The methods of cooling load are, the first one is the transfer function method, which is by using transfer function, which is by applying the transfer function equations. The second one is the cooling load temperature. The second one and the third one, they are quite similar, is by using tables of temperature and different cooling load. The third one is the hand calculations, which is by applying what we took in air conditioning system, in air conditioning course. And the last one is the hourly analysis program, HAP, which is the most updated software in engineering field, which is being used for modern.
Use the software.
This software, the hourly analysis program, HAP,
It's software.
software, yeah. It's being used in modern buildings for calculating the cooling load for the building, and it's quite simple and easy and fast at the same time. Also, it's accurate and precise when it comes to results. Moving on, Dawood now will explain our calculations in details.
Hello, my name is Dawood, and I want to talk about the calculation of the cooling load. In our project, we used 2 different methods of those 6. We used hand calculation and hourly analysis program. But in hand calculation, it was long. It was a long method, so we then used the hourly analysis program. There is one most important thing that we have to say for the cooling load. We have internal load and external load. And to make this process more easier, to calculate the cooling load, to make it more easier, we have to divide our space or our commercial building to small zones and to calculate the cooling load for each zone separately. Let's imagine that we are sitting in that zone and we want to calculate the cooling load for this zone, this room, and we have to ask ourselves many questions, like how many lights that we have and what is the voltage for each light. Is there any coffee machine here? Is there any food warmer or microwave? What is the activity here? Just I saw someone standing and it was Dr. Grading and I'm explaining. So the latent and the sensible heat are different between each one of us. And the ventilation, by ventilation, it's the desired air that across this room by mechanical machine.
So you need external load?
Yeah, this one for internal loads.
This is
Yeah, for the internal loads, yes. And for the external loads, that we have to know what is the insulation material in this wall and how many layers in this wall. And this glass, it is double glass or single glass. And we have to calculate the solar radiation that across this room by this unshaded area. Everything we explained, everything is there by the equations, as you can see. For the external loads, we have some equations, and the U, it's the overall coefficient for the doors, walls, and windows. Area is the wall area or window area. Delta T is the different temperature between outside and inside. And we have the Q transfer. It's for, as I explained, it's for the unshaded area. Solar heat gain factor and shading coefficient. We already took those numbers from ASHRAE. Then we have the Q sensible, Q latent for infiltration, and you have the equation there. Then the internal loads equation. As you can see, we have occupants, that the number of people, and the sensible heat gain. So when someone is sleeping, he give he give less sensible than the one who are teaching or explaining. Then we have the lighting, as I said, it's depend to the light and how many lights and what is the type of that light, and all of these number we took it from ASHRAE standards. Then we have the appliance, so if there is a coffee machine or food warmer, the heat will be more. Then we have the Q sensible and the Q rating for the ventilation. After that, we have to sum all of these heat to have the total heat and for the cooling load. This part for the hand calculation. Then we did the same for our room in the hub analysis, hub software. As you can see, this is our result from the hub. As you can see, and we know that in the basement we have more kilowatt than the ground and the first floor, because in the basement we have some restaurants. So in the restaurant we have some grill, food warmer and microwave, so the heat will be more higher. Then we have a small comparison between hub and hand calculation. We took showroom number 4, it's an example to comparison between the hand calculation and the hub analysis. We saw that there's a small difference between them. In hand calculation, we found that the total equal 11.6 kilowatt, and in the hub result it's 13.9.
That's what you told me.
This is the total heat for the room, external and internal. Because showroom, it's not there's no unshaded area. All the space around showroom number 4, it's conditioned. So there's a small difference. This is because some mistake, human mistake in the hand calculation. Now I will let you with my friend Hussein. He will talk about the
Hello. So the VRF system is using a heat pump or heat recovery system, which means the VRF system is using a heat pump or heat recovery system, which will provide powerful heating and cooling for all indoors and outdoors units. The outdoors units it has a compressor with a driven fan, which means the speed will be different by adjusting the frequency of the power supply. We can see here that the pipe's diameter is 0.5 inch, and in the ground floor we will have 19 indoor units with 3 distributors. These 3 distributors will have 3 outdoor units. And the pipes.
The pipe diameter is
It's a VRF system. This system is ductless. We don't use ducts. We just use pipes.
pipes.
Yeah.
There are pipes inside for VRF system that it's small. Not saying this one, but this is not using the VRF system. It's smaller.
These pipes, the green one will have inside it the subcooled liquid, and the red one will have the superheated gas. For the first floor, we will have 10 inlet door with 4 distributors. Here in the basement, as you know, that we have restaurants here, so we will have 25 indoor units with 5 distributors. We will see here that the outdoor units we will have 12 because we will have 12 distributors. For each distributor in the room, we will have an outlet door. So in total, the quantity of indoor units is 54. 19 of them will be the two-way cassette, and 35 will be the round-way cassette. For the outdoor units, we will have 12 in total. So 3 of them will be the top discharge heat pump up to 104 horsepower, and 9 of them will be the top discharge heat recovery to up to 88 horsepower. This is our work plan. So in conclusion, we choose the VRF system since for our project, since it's more suitable for such a large modern building, and we use the hub software because it's more accurate to calculate the cooling load, which is in total 373.5 kilowatts. We also use the AutoCAD software to distribute the inlet units and the pipes. For future work, for who will redo this project, they should be aware that the properties that we use it's in Kuwait, related to Kuwait, and the catalog is related to Carrier Catalogs company. And this is our reference. Thank you.
Dr. Sidis?